In this video, I want to show how you could decide whether 2/3 is greater or smaller than 3/4. In the first method, I'm going to fold two strips of equal lengths into one of which I'm going to fold into quarters, and the other one I'm going to fold into thirds. So I'm going to start by folding the first strip into quarters because it is the easiest to do. I'm going to make one fold. I'm going to fold into half, and then I'm going to fold the two layers into half as well. And so this easily gives me a strip in quarters, out of which I'm going to draw dividing lines over here to break them into quarters. Here you go. And one over here. Right. So this would be 1/4, 1/4, 1/4, and 1/4. So 3/4 would be three of these. Now I'm going to fold now the other strip into thirds. Pretty easy. You're going to you're going to fold this strip into unequal lengths so that one side is half as long as the other. So there we go. Right. So if you check, you should find that these thirds form a whole, one whole. So three of these thirds form a whole. And so I'm just going to draw a line here to mark off 1/3, and another line here to mark off the other 1/3 and 1/3 over here. All right, so it is pretty obvious here. You can tell that 3/4 is more than 2/3. Now, in the second method, I'm going to show how you could compare these two fractions if you don't actually have the strips with you on hand. So with your imagination, you could further break each of the parts into smaller parts so that the total number of parts in each of these two strips are the same. So let's take a look at this. All right, I have 3 and 4. 3 is for the thirds and 4 is for the quarters. They are from the bottom numbers, or what you call the denominators of the fraction. So here's what happens. Now if I split each of the thirds into two parts, I will end up with 6 total parts. If I split each of the thirds into 3 equal parts, I will end up with 9 total parts. If I split each of the thirds into 4 equal parts, I will end up with a total of 12 parts. Whereas for the quarters, if I split each of the parts into 2, I will end up with a total of 8 parts. If I split each of the quarters into 3s, I will end up with 12 parts. Now, so you notice straight away that I have a situation of a possible combination where I have where I can form 12 parts from the thirds and 12 parts from the quarters. So I could break each of the thirds into quarters, and I could break each of the quarters into three parts. So there we go. Two thirds if I break each part into 4 smaller parts, I'll end up with 12 total parts. And so then these 2 parts become 8 out of 12. Whereas for the 3/4, if I break each of the 4 parts into 3 smaller parts, I will end up with 12 parts. And these 3 parts become 9 out of 12. So this means that 2/3 is equal to 8 out of 12, and 3/4 is the same as 9 out of 12. And it becomes really obvious from this that 3/4 is actually larger than 2/3. Now, to physically show what actually happens, let's take a look at the 2/3. So I'm going to fold each of these into 4 smaller parts. So here you go. Oh, sorry. I'm going to fold each of these into 3 smaller parts. I apologize. Okay, so we're going to fold each of these into 3 smaller parts. All right. So once that's done, all right. So now I have a total of 12 parts. You can see this 1/4 has become 3 out of 12. 2/4 becomes 6 out of 12, and 3/4 has become 9 out of 12. I'm just going to delineate the lines better. So 3 out of 12, 6 out of 12, and 9 out of 12. Whereas for the 1/3, I'm going to fold each of the thirds into 4 smaller parts. That's half. It's half. It's half. And then I'm going to fold them one more time. There you go. All right. So take a look at these further splits. So my first 1/3 becomes 4 12s. If I combine that with the second 1/3, I would have 8 12s. So 9 12s, 8 12s. So 3/4 is more than 2/3.